Okay, welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. In this video, we're going to be looking at the first lesson of the Year 12 Advanced topic, Motion and Rates. So the first lesson is average velocity and speed. So by the end of this lesson, you'll be able to calculate displacement, distance, velocity, and speed. So let's have a look at the first part of this lesson, which is motion in one direction. In this unit, we'll be looking at how particles or objects move in one dimension, so up and down or side to side from left to right. For all of these kinds of problems, we need to look at only the first and sometimes the fourth quadrant on a Cartesian plane. This is because our horizontal axis is time, which can never be negative. So here we've got our first quadrant, and here we've got our fourth quadrant. Okay, we don't have the second or third because we can't have negative time. There is an example of one of these graphs on the right. Okay? So if we have a look at this example here, it's saying as time goes along, we can see that the particle is going up, and then it's coming down towards where it started, and it's going below where it started, and then it's just staying. Or we can say it's going to the right, because it's positive, then it's going left, then it's back where it started, then it's going to keep going left, and it's just going to stop moving. It's just going to stay in the same position. Okay, so consider a bouncing ball, where the height above the ground, x in meters, is given by the formula x is equal to 5t bracket 8 minus t, where t is time in seconds. Find the ball after 1 second. So this is nice and easy. When t is equal to 1, the height is equal to 5 times 1, times 8 minus 1. 5 times 7 is 35. Okay, so 35. Now, because x is in meters, I'm going to write meters. Alright, question B. At what other time is the ball at the same height above the ground? Why don't you pause the video and have a go with this one? Alright, so question B. When is it also 35 meters? So I'm going to write 35. I'm going to sub 35 where x is. That's going to equal to 5t bracket 8 minus t. I'm going to expand the brackets to give me 40t minus 5t squared is equal to 35. I'm going to move everything to the left hand side to make this minus 5t squared positive, because I want a positive t squared. So I have 5t squared minus 40t plus 35 is equal to 0. I'll then just divide everything by 5. Okay, and can only do that if we have an equation, right? If it equals 0 or equals something, then you can divide it. Otherwise, you have to factorize it out. Okay, otherwise you have to do that if it's not an equation. Anyway, we can see we've got a mnemonic here. So I'm going to factorize that to t minus 7t minus 1 is equal to 0. So t is equal to 1 and 7. Okay, well, we already knew that that the height of the ball is 35 when t is equal to 1, because we've already done that here. Therefore, the other time is 7. Therefore, at t is equal to 7 seconds, the height is the same. Alright. Let's have a look at velocity and displacement versus speed and distance. So similar to our previous studies in vectors, velocity and displacement have direction, which means they can be negative. Okay, so if we have a negative velocity, it means it is moving to the left. If it's got a negative displacement, that means it's to the left of where it started. Okay. However, speed and distance are magnitudes. Okay, so remember we use the absolute value for the magnitude of a vector. Okay, because it has to be positive. So speed and distance have to be positive, so that they are magnitudes, meaning we ignore the direction. So that means if a velocity is minus 7 kilometers per hour, then the speed is actually just 7 kilometers per hour, right? If the displacement is minus 5 meters, well, the distance is just 5 meters. Okay, so this just means it's 5 meters to the left of where it started, or the origin, and this is just the distance, just 5 meters. Okay, so for many of these questions, we will be using the old classic d is equal to st. Okay, some of you may have learned this as a speed pyramid, d over st. So if we want to work out distance, it's speed times time. If we want to work out speed, it's distance over time. If we want to work out time, it's distance over speed. Okay, so we've already learned this like many times already in previous years. So let's have a look at example 2. Consider again x is equal to 5t bracket 8 minus t. Find the average velocities of the ball during the first second and during the 5th second. Maybe I'll get you to pause the video, see if you can have a go with this. Otherwise, I'll go through A and then you can pause the video and have a go through B. Alright, so question A. During the first second is when between t equals 0 and t equals 1, right? Because that's the first second. So when t is equal to 0, what is the height of the ball? Okay, so the height of the ball is just going to be 0. Because 5 times 0 is 0, 0 times whatever that is will be 0. When t is equal to 1, we already worked out previously that the height of the ball is 35, right? 5 times 7. So we can see here that the average velocity, we're going to take the end, so always the last one, so 35 minus 0, and then divide it by how long it took, 1 minus 0. That's going to give us an answer of 35 meters per second. Alright, so that's the average velocity, and because it's positive, that means it's moving to the right, or moving up. Okay, one or the two. Alright, so if you needed that, maybe pause the video, have a go with B now. Alright, question B. During the 5th second means between t equals 4 and t equals 5. So when t is equal to 4, you can see that the height of the ball will be 20 times 4 will be 80. When t is equal to 5, we've got 25 times 3, which is 75. Okay. So therefore the average velocity, so what we're going to do is we're going to take the last one, because 5 occurs after 4. So 75 minus 80 over the 5 minus 4. So that's going to give us minus 5 over 1, which is just minus 5 meters per second. Right, so that means it's actually moving downwards. Okay, at this speed. It's moving downwards at a speed of 5 meters per second. Alright, find the average velocity and the average speed of the same ball. Assume 0 is less than or equal to t, which is less than or equal to 8, during the 8th second and during the last 6 seconds. So why don't you pause the video and have a go with these two. Okay, so during the 8th second means between t equals 7 and 8. So let's do part A. When t is equal to 7, what is the height? So I might just do it like this. 5 answer 8 minus answer. Okay, 35. When t is equal to 8, x is equal to 0. Alright, so average velocity, take the last one minus the previous one over the time. So that's minus 35 over 1, which is minus 35 meters per second. So we've done average velocity. We also need to work out average speed. Okay, so average speed we need to work out as distance traveled over time taken? Well, we can see here that the distance traveled was from 35 to 0. So it's 35 minus 0 over 1, which is just 35 meters per second. Okay, so remember, speed has to be positive, velocity doesn't, because speed is the magnitude of velocity. But what about B? Okay, during the last 6 seconds. So because we know that the equation of this, x is equal to 5t bracket 8 minus t, when we expand this out, we know that's a quadratic. So that means it's going to be in the shape of a parabola. Now in the last 6 seconds, it's not always going down. Okay, so it might be best if we graph this. I'm just going to be looking at this one here. We know that the zeros of this function is 0 and 8. Okay, because t has to equal to 0 or t has to equal to 8 in order for x to equal to 0. And therefore, halfway between them will be our turning point. Okay, or we can look at this one here. If we were to write this as minus 5t squared plus 40t, remember the turning point is minus b over 2a. So that's minus 40 over 2 lots of minus 5 minus 10, which is 4. So we know that the turning point will be at 4 something. What is that something? Well, let's put it in 4 up 80. 480 is the turning point. Okay, so it's going to look something like that. So during the last 6 seconds, we need to work out 2. So when t is 2, x is equal to 60. Okay, so that's 60. So that means we can see here that's moving up 20 meters, okay, from 60 to 80, and then it's going down 80 meters. So that'll be important for speed. But when we're working out velocity, it's exactly the same thing. Average velocity. Actually, let's just do the last bit. T is equal to 8. X is equal to 0. So the average velocity is 0 minus 60 over 8 minus 2. Minus 60 divided by 6 is minus 10. So minus 10 meters per second is the average velocity. But what's the average speed? Well, average speed is actually equal to the distance traveled divided by the time taken. Well, the distance traveled is 20 plus the 80, which is 100. How long did it take? Well, 8 minus 2 is 6. Well, we knew because it says the last 6 seconds, so just divide by 6. So when we do that, 100 divided by 6, we get 16 and 2/3, or 16.67. I'll just do it to 2 decimal places. 16.67 meters per second to 2 dp. Right, so we can't just absolute value that because we know it's the magnitude. Magnitude just means it's positive, right? It can't be negative. But we can't just absolute value that because speed is distance over time. What is the distance traveled? Well, the distance traveled is 100, not the 60 or not 80, because it's still going up 20 and then down 80. Alright, so that's it for this video. I know it was a short one, so maybe you might be able to have a look at the next lesson, lesson 2, in the same period. Alright, so if you found this video helpful, please give it a like and subscribe. See you guys.